हेलो सर, तेज सर। हेलो तेज सर। सर साउंड लास्ट मिनट सर। ఇప్పుడు దగ్గర సార్, ఇప్పుడు దగ్గర
ఓకే కదా. ఢిల్లీ సార్ ఒకసారి
చెప్పండి సార్, ఢిల్లీ సార్ ఫోన్ చేసి జాయిన్ అవ్వమని. సంతోష్ కూడా జాయిన్ అవ్వమంటే బెస్ట్. ఇవాళ వెళ్ళలేదు కదా వాళ్ళు. సంతోష్ కూడా ఫోన్ చెప్పేస్తున్నాను. అయింది కదా పాత మళ్ళీ బయటకు వచ్చేప్పుడు మళ్ళీ బయటకు మీరు హోల్డ్ లో పెట్టారు. ఎవరు హోల్డ్ లో పెట్టారు? సార్ మీరు హోల్డ్ లో పెట్టారా? అదే కనిపిస్తుంది. సంతోష్ బయట ఉన్నావా, అది ఇటు ఉన్నావా? ఒకసారి ఆ మీటింగ్ జాయిన్ అవుతా అని. ఓకే మీకు ఆల్రెడీ లింక్ పంపించాను చూడు. ఓకే ఎవరి బిజీగా ఉన్నారు. ఈ FDP విజిట్ చేస్తారని బాగా తెలియదు.
రావు గారు జాయిన్ అవుతారు.
ఓకే
అతను వచ్చారా? వాళ్ళు వస్తే ఎలా కొట్టిండి అతను ఎల్లుండి స్పీకర్ అనమాట. అతను జస్ట్ వెంటనే ఉన్నారు వెంకటేశ్వర
వస్తేనే ఎలా కొట్టేస్తాను సార్. ఎవరు వచ్చినా ఎలా చేసేస్తాను సార్. వాళ్ళు అవ్వాలి. అసలు పొరపాటున ఎవరు వచ్చినా యాక్సెప్ట్ చేస్తారు. సార్ ఢిల్లీ సార్ ఎక్కడ పోయాడు, ఇంకా రావట్లేదు సార్. మీకు వాయిస్ వస్తుందా?
మీరు పెట్టేస్తారా?
సంతోష్ మైక్రోసాఫ్ట్ టీమ్స్ లింక్ రాలేదా? నీ మెయిల్కి వచ్చి ఉంటుంది. నీ మెయిల్కి. ఓకే లింక్ రాలేదు సంతోష్. నేను మెయిల్ పెట్టాను సార్, నేను మెయిల్ చూడలేదు. ఏదో వినిపిస్తుందా? స్పీకర్స్ పెట్టారా
సార్? మీరు ఎలా అండి, మీరు ఎలా అంటే చెప్తాను.
ఇది అడ్మిన్గా మీది రైట్ క్లిక్ కొట్టి చేసి ఇవ్వాలి.
అంతే సార్.
గ్రూప్ అడ్మిన్
సంతోష్. సంతోష్ హలో సంతోష్. సంతోష్ జాయిన్ అయ్యాడు. సంతోష్ 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 ఒకసారి మాట్లాడతాను.
ఏం చేస్తున్నారు?
వెరీ గుడ్ మార్నింగ్.
సరే, నేను మళ్ళీ ఫోన్ చేస్తాను. ఓకేనా? వెళ్తున్నారు తస్సు అన్నయ్య?
బయట సౌండ్ వచ్చేస్తున్నాయి. ఓకే నువ్వు మ్యూట్లో పెట్టే చెప్తాను. హలో దిల్లేశ్వరరావు. హలో దిల్లేశ్వరరావు. హలో దిల్లేశ్వరరావు. వినిపిస్తుంది. నేను మాట్లాడతాను చూడు. వినిపిస్తుంది చూడు. Very good morning. Welcome to all invitees and participants in this 3-day faculty development program on environment solution, sustainable technology service control, EPSTC. Happy to say that the chemistry division in the BSH GMRIT is FDP on the theme of environmental problems, challenges, current methodologies adopted to mitigate the pollution and provide clean and healthy environment. Now I request that this year we also.
సార్, మీ వీడియో ఆఫ్ చేశారా? వీడియో ఉందా? వస్తుందా? నాకు రావట్లేదు
సార్. వినిపిస్తుంది సార్. It's nice. అవునా? మాకు బాగానే ఉంది సార్. తీసుకుంటే వినిపిస్తుంది మాకు.
ఢిల్లీ, నీ వీడియో ఆన్ చేయరా? ఢిల్లీ
సార్ చేశాను. కనిపిస్తున్నా సార్. చూడండి, మీరు కనిపిస్తున్నారా? తోటి సార్ వీడియో కనిపించట్లేదు. ఆడియో ఆఫ్ లో ఉన్నారు. సంతోష్ కూడా ఆఫ్ లో ఉన్నారు. మీరు ఒక్కలే కనిపిస్తున్నారు. తేజ కూడా కనిపించట్లే. సంతోష్ కనిపించాడు. స్పెక్ట్ పెట్టుకోండి. గ్రాముడు కనిపిస్తుంది. సంతోష్.
ఢిల్లీ
తేజ నువ్వు కనిపించట్లేదు.
ఢిల్లీ, నేను లైవ్ ఇస్తాను నీకా?
సంతోష్ నాకు కనిపించాడు. ఇందాక వచ్చి వెళ్ళిపోయాడు సార్. ఇప్పుడు మళ్ళీ బ్యాక్ వెళ్ళిపోయాడు. చూడండి, నాకు రీసౌండ్ వస్తుంది మాట్లాడితే. సంతోష్ వచ్చాడు. సంతోష్ వచ్చాడు చూడండి సార్. కనిపిస్తున్నాడా? మాకు కనిపిస్తున్నాడా? అవునా, కనిపిస్తున్నాడు సార్. ఓకే ఓకే ఓకే.
సార్, లింక్ షేర్ చేస్తున్నా, ఇక మీరు మాట్లాడద్దు.
Sir, good morning, HOD sir. Arun sir, good morning. Arun sir, is it audible?
Dilesra, good morning.
Sir, good morning.
Baro.
Good morning. Virgopal. Good morning. Okay.
Good morning, Venugopal sir. Good morning, sir.
Good morning, Andy. Venugopal garu. Namaste. Venugopal garu, namaste. Am I early?
No.
No, sir, not at all. I think.
Is my voice audible? 2 minutes.
Yes, sir. Yes, sir.
Okay. How many participants registered?
Around 250.
How many?
250. 250.
Okay.
Virgopal.
Yeah, tell me. After your voice is a bit low. Be louder.
Okay. Ipudu? Is it audible?
Still be louder.
Is it audible?
Now it is audible.
Okay. After inaugural remarks, we will proceed to your FDP program. Your talk.
Still your voice is a bit low, Nana. Just increase the volume.
Okay. Volume is fully increased. So now?
Now it is okay, but very low.
So your audio is 100%.
What about my voice? It is okay?
It is okay.
Fine, sir. It's fine, sir.
It is okay.
Okay.
Maybe my voice may be weak.
You just go through your sound settings, sir.
Okay.
Once.
Okay.
Baragar, speak loudly. Don't disturb now any sound system like that. You are audible, but you can increase, sir.
Okay, sir.
Not more than that.
Okay, sir. So today clear. Today FDP program. Is it audible?
Yes, sir. Yes.
Okay. Just sir, 1, 2, 3. Audible, sir?
Audible, sir.
Okay. Hello, Gopal.
Yeah. Now it is good.
Okay. Just 5 to 10 minutes we will start.
Okay.
Please on the line. Only formalities. Follow. So your class is completed?
Yeah, 11 to 11:30 I closed.
Okay.
10:50 to 11:30 I closed. You are not coming to Vizag all these days?
No. I'm staying in Vijayanagara only.
Okay. How is?
Yes, sir.
Okay.
Am I audible to you? Yes.
Please on the line. Wait. Dilesra,
Sir,
yeah.
it's audible, sir.
Okay. About 5 more minutes.
Yeah, no issue.
Okay.
The topic pollution control to nanotechnology. Like I said, the topic. Align it with that.
సార్ జాయిన్ అవుతున్నారా? ఓకే సార్ కూడా జాయిన్ అవుతారు. ఓకే సార్ జాయిన్ అవుతున్నారంట. సార్ జాయిన్ అయ్యి స్టార్ట్ చేయండి. జాయిన్ అయ్యారా చూడండి అక్కడ వస్తుంది.
Sir, is it audible? Is it audible?
Yes, sir. Audible, sir. Audible, sir.
Good morning. Is it audible?
Yes, sir. Audible.
Is it audible?
Yeah, quite audible. What about my voice?
Okay, very clear.
Okay.
So, very good morning. And hearty welcome all invitees and participants to this 3-day faculty development program on environmental pollution, sustainable technologies for its control, EPSTC. I am Dr. Rameswara, convener of the FDP. Happy to say that the Chemistry Division, Department of Basic Science and Humanities, GMRIT Institute of Technology is organizing this FDP on the theme of environmental problems, challenges, and the current methodologies adapted to mitigate the pollution and provide clean and healthy environment. Now, I request our principal sir, Dr. CLV Prasad to give another remarks on this FDP. Sir, principal sir.
Thank you, Dr. Subbarao.
Thank you, sir.
Good morning to all of you, and I'd like to welcome all the guest speakers and the participants for this 3-day faculty development program titled Environmental Pollution, Sustainable Technologies for its Control. I'd like to compliment the Basic Science Engineering Department and in particular Chemistry Department for having chosen this topic, which is very much apt for the current days. So you know that environmental pollution is a very a prime focus area, which is there being focused, but the question is sustainability. Everybody is taking up a lot of precautions, and new technologies are coming in for minimizing and reducing the pollution. But still, if you look at sustainability, that is a big question mark. I'm sure that this topic and the deliberations that are going to happen in these next 3 days will enlighten all the participants about the various the technologies, particularly sustainable technologies, because all these things are leading to sustainable goals. Ultimately, for any country development, and somewhere you need to narrow down to the sustainable goals. So this is pollution is one of the environmental pollution is one of the sustainable goal, where all of us are working towards that. And I would like to thank Professor N.V.S. Venugopal professor from Geetham University for accepting the request and being a part of the speakers for this 3 days workshop. Thank you, Professor Venugopal Garu.
Thank you.
Thank you, and I'm sure that it is a great opportunity for all the participants to listen to you and to understand the insights of the topic, what is it you're talking about. And I would like to also thank Dr. K. Srinivas and also Dr. T.N.V.V. Rao for accepting as speakers for this 3 days program. In fact, during this pandemic, that is since March 2020, the situations that came around and the situations and the experiences what everybody across the globe had for the last 6 months, it has given altogether a different dimension for the thought process of everybody. Anybody across the globe, maybe a person from education sector, maybe from industry, or maybe from any sector, it has given a different dimension for the thought process. And it has brought all the systems to a new normal. So now that we are coming into a new normal, what are those challenges that we may face post-COVID is a very big point of discussion. And I'm sure that all the deliberations that we'll be doing for the next 3 days, somehow finally again we need to narrow down, because when you're looking at sustainability is that which ultimately possible only if you take the situation into account and make the things happen. So all the deliberations what will be happening next 3 days will be moving more towards enabling mode. So enabling mode in the sense they have to take the challenges that they come due to this post-COVID. And the COVID has disrupted the entire system. The entire system in the sense, a lot of people lost their livelihoods, a lot of people lost their lives, and a lot of industries were shut down. And at the same time, it has given a different dimension and scope and new opportunities for new industries to come in. Now, if you compare the new industries or the industries which are doing with 10x performance, can you imagine? Under even this COVID, there are some industries which are working with 10 times the regular performance, like your e-commerce, cargo, logistics, pharma, and then your agri products. So there are some industries which are working extremely well. At the same time, there are some very good number of industries which are badly hit. So there is something like a situation which was never expected, and I think that we are only the current generation facing, and hope so that we'll not have any other occasion with such a situation we'll be facing in future. So keeping all this in mind, I'm sure that these deliberations will give or trigger the thought process in the minds of all the participants to get into a sustainable solutions for the topics under focus. So with these few words, I'd like to welcome all the guests, participants, and also compliment all the organizing team for doing this program. Wish you all the best. Good luck. Thank you and have a nice day.
Thank you, sir. Now I request our Deputy Department, Dr. R.L. to speak few words on this FDP.
Thank you, Mr. Barrow. Respected Vice Principal, Dr. Raja Murdas, and our beloved Principal, Dr. RSV Prasad, esteemed resource persons, and my dear participants, good morning. This is Dr. R.L. Naidu, Head, Department of Basic Science and Humanities. This Basic Science and Humanities is a combination of 4 departments, namely Maths, Physics, Chemistry, and English. On behalf of Basic Science and Humanities, I welcome you all to this 3-day faculty development program titled Environmental Pollution, Sustainable Technologies for its Control. Few words about our institution. GMR Institute of Technology has established in the year 1997. Our institute is running with 7 UC programs. All are accredited by NBA under Tier 1. And all departments are running PG courses. This institution is also accredited by NAC with A grade. Also, GMRIT is ranked in the bandwidth of 201 to 250 at a national level by NIF. Institute also bagged #1 cleanest campus in India among the private engineering colleges. This is about our institution. Coming to COVID, you all know education suffers from the crisis of COVID-19. As our principals are rightly told, it has influenced every aspect of life and resulted in a huge change in the outlook of living life. We have to change our lifestyle for our survival. In my opinion, this pandemic have a positive impact on the education and economy. However, at the same time, it reshaped the entire education system. In the present day teaching process, online learning system was brought up in a very short period of time. Tremendous initiatives have been taken by academicians and institutions to promote online education. In the last few months, higher and technical education institutions have made significant efforts to keep pace with the arising out of the present crisis with flexibility. Universities have a great opportunity to prove their credibility in society that can serve as sources of knowledge and sources of expertise for the society. Coronavirus related disruption may give teachers time to rethink in the area of education reforms. This COVID has making disaster over the entire world, but on the other hand, it made the people closer through the existing technology. Most of the faculty members are benefiting with these webinars and FDPs. During this COVID season, our principal and vice principal have given opportunity to conduct webinars and FDPs. Through these sessions, faculty of various institutions are benefiting a lot with the lectures of renowned academicians. In the series of GMRIT FDPs, this is one FDP. With these few words, I hope all the participants will benefit from the eminent resource persons in our FDP. This is from the FDP. So thank you, the team of chemistry wing, for giving me this opportunity. Wish you good luck, all the participants. And Venugopal Garu, thank you very much, sir, for accepting our invitation. Thank you. All the best. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Okay. Now with these inaugural remarks on FDP, we now proceed to the program. May I now request Dr. Ravi Sir to introduce today's speaker, Professor V.S. Venugopal, Getam University, who will be speaking on pollution control through nanotechnology.
Thank you, sir. A very good afternoon to respected dignitaries and respected participants. It's my immense pleasure to introduce a versatile personality who always believes that education is the passport to the future. For tomorrow belongs to those who prepare for today. And he is none other than Dr. N.V.S. Venugopal Garu. Dr. Venugopal Garu done his PhD from Andhra University in 2004. He has 27 years of experience in teaching and research. Now, he is a professor of chemistry in Getam University. Formerly, he acted as various positions such as a deputy director for student affairs and admissions in Getam University. He is a member in World Research Council, London Press Council, World Science Congress, etc. He was received various rewards and awards such as Best Researcher in Nanoscience in 2019, powered by World Research Council. Most of his research papers are awarded as best papers in various conferences. He was authored a book with Professor Nemani Krishnamurti, and in Telugu, the title is called Manava Manugadalo Rasayana Shastra Vijnanam. This book represents the importance of chemistry to all human beings. He has published more than 45 research papers in well-reputed journals. In his credit, 5 PhD has been awarded under his esteemed guidance, and still some students are also doing research. We know that nanotechnology in environment pollution is going to have a major impact on the survival of human race. So how the nanotechnology plays a major role in pollution control is understood by his valuable words. Now, I request Professor Venugopal Garu to take over the session to present his valuable words about pollution control through nanotechnology. Sincere welcome, sir. Thank you.
Thank you, sir. Now I request Professor V.S. Venugopal to give the presentation of this talk.
Okay, good morning everyone. Just let me share my PPT, then I will start my lecture. Can you allow Dileswara Garu?
Yes, sir. Yes, sir. Welcome, sir. Please start, sir.
Yeah, good morning again, all of you. And it's my pleasure to say special thanks to my friend Dr. Subbarao and for giving this opportunity. And I congratulate the GMRIT Basic Science and Humanities, in particular Chemistry Department, for doing this particular faculty development program, which is very relevant to the present situation. And initially, the principal GMRIT said a few remarks about the present status of COVID. Is it Subbarao Garu? Is it audible?
Audible.
Yes, sir. Yes, sir. Yes, sir.
Yes, no audible.
Yes, sir. It's audible, sir.
Yeah. There are two E's in particular, to my view, that received adverse effect because of the pandemic situation. One is economy, and the one is education. These two E's were suffered, but in spite of this adverse situation, we, the teaching fraternity, are doing enormous extent of what you call widespread activities, faculty development, online faculty development programs, conferences, and workshops, etc. It is the most wanted thing at the present situation. Now, my dear friends, now the title of my talk today is pollution control through nanotechnology. We all know about the status of the pollution worldwide, and the World Health Organization, they says that 9 out of 10 people, yeah.
Please full PPT.
Yeah. It's okay? Just a minute. Again, I will share otherwise. Okay. Subbarao Garu is okay?
It is okay.
Yeah.
Please put your slide slow.
Yeah. Can I keep it in slides mode? I think you should enable my face, I think, there.
Is it problem?
No problem. Can I continue?
Just 1 minute.
Yeah.
Zoom.
Full slides.
Full
Slides కనిపించాలండి.
Where is Gopal?
Yeah.
You can make full slides.
Yeah. I'm doing.
I think press F5, sir. Press F5.
Yeah.
Press F5. I think it can get big screen. First slide.
Yeah. I did it. This is the full slide. Yeah. It is not visible.
Phone is చూస్తారా?
Yeah, this is full slide.
Just 1 minute.
Yeah. Slide is okay?
No.
You're not getting my slide?
No.
Again, I'll do.
Okay.
Yeah, it's okay.
At present it is not
I
visible.
continue. Not visible. Slide. Just a minute. Now?
No. At present slides are not visible.
Just a minute.
Okay.
Now okay? Okay? Now okay?
No. At present
No,
not
it is a full slide. Can I do again?
At present slides are not visible. Slides are not visible. Okay. When about proceed? Okay.
Yeah.
When about proceed?
Visible?
Okay, visible.
Sorry, I apologize.
No problem.
Okay, my dear friends, according to the World Health Organization, says that 9 out of 10 people on the planet can't breathe properly and it kills 7 million people each year. Now, this is a very, very striking, what do you call, thing that one must think of about the pollution. Now, we know so many aspects of pollution, and what exactly pollution means. Any harmful substance contaminate the environment, we say it is called pollution. And pollution always refers to a very bad condition of environment in terms of quantity or quality. So if you look at this slide, is my slide visible? Delesrao garu, is my slide visible?
Oh,
Yes, sir. Yes, sir.
Yeah. Okay, fine. Now, I request all of you kindly go through these photographs. Some photographs I have kept here. And this is the present status. Now, we say when harmful substances contaminate the environment, we say it is absolutely pollution. And if you look at the man-made pollutants, if you look at how water is being polluted, how pollutants are entered into the environment, this is the adverse scenario if you look at the present stage. Now, different sorts of pollution. We try to understand what exactly pollution means in different types. We have air pollution, soil pollution, water pollution, plastic pollution, thermal pollution, land pollution. These are all different kind of pollutions where we are thinking of to control, sometimes to prevent also. But we all know the widespread prevalence of environmental pollution began with the birth of the Industrial Revolution in the year 1900 onwards. And over the years, so many factories have increased, and they are the reasons for different levels of pollutions that are in front of us. So Industrial Revolution gave the unprecedented amount of pollution we are having. So we need to control these different types of pollution. So now how we are going to do that is the most challenging task to the world scientists. Now, what it is doing means the blanket of Earth suffers. That means the atmosphere is suffering because we are polluting the atmosphere. That is the main reason. Now, what are the biggest contributors to pollution in India? If you think of our industry, what is the main contributor as far as pollution is concerned means right from sewage waste to radioactive waste. That means almost more than 10 different areas. The biggest contributors we would like to witness, be it metals, oils, plastic, or glass, or sometimes electronic waste, radioactive waste. So these are all different contributors. Now, what these contributors are doing, these contributors are giving adverse effects to us. That means we are suffering. That means the people are suffering. The health problems we are getting, and our agricultural field is suffering. And monuments are receiving some damages. Aquatic life gets destroyed. Groundwater gets affected. Farming is not possible. And agricultural field water, if you analyze in certain parts of our country, it is in alarming situation. They crossed the permissible limits all the 24/7, 365 days. Now, these are the effects that we are going to get as far as pollution is concerned. Now, coming to human health, everyone now in the world, they are thinking of human health because of the COVID pandemic situation. We received a lot of knowledge as far as human health is concerned because of this pandemic situation. Now, health effects of pollution. Now, be it air pollution or water pollution or soil pollution, these are the three important types of pollution. So we are raising almost 90% of health problems or adverse effect towards human health. That's very, very important for us. Now, if you look at some facts, 21% complaints we are getting from air, and 15% from wastewater, and 13% because of the order of certain materials, and 14% from the solid waste. Noise also is 11%. Now, if this is the situation, the complaints, environmental complaints that we are receiving today. Now, coming to major air pollutants, everybody knows this: carbon dioxide, sulfur dioxide, nitrogen oxide, carbon monoxide, and particulate matter. We have so many strategies are there to control these air pollutants, and so many methods were actually followed in certain areas to control this major air pollutants. But amongst all types of pollutions, all countries in the world, they give a lot of importance as far as air pollution is concerned, because of the diffusion parameters, because of enormous quantities of undesirable gases are entering in air. This air pollution received the topmost priority for us. And if you look at the deaths, just now I explained WHO statement that 7 million people every year, they are dying because they are unable to take good vegetable air. No, this air pollution is the most important thing. That is the reason that strategies and technologies have given top priority as far as the control of air pollution. Now we have some legislations. Everybody knows these environmental legislations. Now, what for these legislations? We can take all these legislations for prevention, sometimes control, prevention and control of pollution. These legislations are there. In spite of these legislations, in some areas, in different continents, we are unable to control pollution. We are unable to prevent pollution also. Now, the title of my talk today is the pollution control. Now, pollution control is a term used in environmental management. It means the control of emissions and effluents into air, water, and soil. These are the three broad categories where innovative technologies are doing a lot of research as far as pollution control is concerned. Without pollution control, the waste products from overconsumption, heating, agriculture, mining, manufacturing, in so many areas, other human activities certainly degrade the environment. Anything which is present in excess in environment, it leads to a pollutant. It gives you adverse effect to us. We have to control that. That is a very, very important thing. Now, control of pollution, if you look at the hierarchy, only two things are there. One is pollution prevention and waste minimization. Whatever the technologies we are talking today, is that technology is for pollution prevention? Is that technology for waste minimization? This is the very, very important aspect. Now, to draw attention about the pollution control all over the world, every year the 2nd December, we mark 2nd December as National Pollution Control Day. This National Pollution Control Day is meant to mark about the four very, very important things. Recycle strategies and how best we are saving energy, how we are minimizing our vehicle use, especially the automobile sector, and why we have to say no to plastic. Now, these are four categories. When we achieve some good results rather than receiving erroneous results, I think pollution control, if you talk about the innovation technologies, we are successful. That's to know the various problems that we encounter, why these strategies or new technologies are not meeting the pollution control. To discuss all these things, we have marked 2nd December as a National Pollution Control Day. Now, we all know pollution control means we have traditional strategies and preferred strategies. Preferred strategy may be the innovative strategy, the latest strategy. In the latest strategy, we always give importance about the reduction of emissions via energy efficiency and conservation measures. But we all know in traditional strategies, reduce, collect, capture, retain the pollutant before they enter into the atmosphere. In a nutshell, reduce the pollution at the source. That is the traditional strategy that we are following actually. But the traditional technologies of placing settling chambers or collectors may be used to control emissions of coarse particulates from power plants and industrial sites. And these were adopting in all countries, be it a small scale industry to large scale industry for the control of pollution. But are we really successful in control of the total what do you call pollution environment? Means it's a question mark. We are not at all reaching even 90% in certain aspects, especially coal and power plants. We are not reaching even 80%. So innovative technology is necessary to control pollution. The particulates must be controlled on site so that the wind does not blow them into the atmosphere. In air, there are certain particles. Their particle size matters. Their particle size give us secondary and tertiary problems for us. Our technology should be fit enough to control the various sized particles which are residing in our atmosphere. That is the very, very important strategy. That is the preferred strategy. Now, what are the best practices all the countries in the world they are following even till today is recycling, reusing, waste minimization, mitigating, preventing and compost. Any country you select, everyone is practicing by adopting these best practices. In spite of following all these best practices, but certain areas in certain conditions, we still require innovative technology. The most sophisticated equipment is necessary to control the pollution, to detect the pollution, to sense the pollution. Still, we have so many best practices, but still we are lacking certain things. That is the reason the scientific community in the world, they are approaching new technologies, novel technologies to control pollution. Now, what are the control strategies in general we have? Control strategy at source, control strategy at the end or the end product. That means right from the raw material to the end user. So what sort of control strategies that we are following? Means we need to inspect the raw material, we need to check our fuel, and all the preliminary examination we have to follow at the source so that we can minimize the pollutants. That is a known fact for us. So in this scenario, we always go for recycling, reusing and byproduct recovery strategies and all these things. And the quality control of every industry, they go for the end of pipe treatment, the primary, tertiary and secondary. And we have certain international organization for standardization, ISO protocols to investigate the pollutants that are coming along with the product and that are actually present in the beginning itself in terms of the raw materials itself. So the control strategies we are following, but where we are lagging, why the need of new technologies are coming out. The point here is whether we are going for control at source or whether we are going for the end user stage, there are certain substances where their particle size is giving us lot of pain for us, unable to control those particles. We need to think of those particles, those small particles which are giving adverse effect, which are changing the property scenario the local environment also. So there should be a sustainable technology that is very, very important to control pollution. Now we have a setup called a Central Pollution Control Board, CPCB. Under that we have ST, State Pollution Control Boards are functioning. When you talk about Central Pollution Control Board, it was established in 1974. What is the objective of this CPCB? Means that they have to control pollution. They have to give clean air. Our country should be called as a clean country. All cities are clean cities. All villages are clean villages, and popularly known as green country, green cities, green villages. This is the motto of this CPCB. But are they moving towards innovative technologies or not? That is a very, very important. Yes, our country is giving top priority for innovative technology for pollution control. Now, this is the talk which I am going to discuss today, the alternative. The pollution control through nanotechnology. This is the latest alternative that we are having. But if I say latest alternative, why I have kept a question mark? Means still we need to receive certain meaningful conclusions and good results. Still we are receiving in some areas erroneous results as far as this technology is concerned. But in certain areas, this technology is the best alternative as far as pollution control is concerned. That is called nanotechnology. No, why nanoparticle? Every one of us, faculty members or research scholars or students, they're having some idea about nanoparticle. We all know small is beautiful. When the particle size is less, it is giving so many advantages for us. Because of its large surface area, or high surface energy, and ability to absorb large amount of substances, now pollutants, and it will catalyze reactions at much faster rate, reducing energy consumption during degradation, or helps in preventing release of contaminants. My dear friends, let me give you one clarity today. Our Indian farmers are using pesticides and fertilizers. Now, for example, 1 acre, if a farmer is using a 5 kilogram fertilizer or 5 kilogram pesticide, now the latest technology, nano pesticide, was available in the market. Rather than 5 kg pesticide or 5 kg fertilizer he is using, he can use only in 1.2 to 1.4 kg nano fertilizer or nano pesticide. Look how much reduction in the source itself. Earlier we used 5 kg per 10 liters. Now the farmer is using 1.2 kg in 10 liters. So the reduction in the size of the amount of the material, we have reduced at the source. That means in the end user, the pollution level is also deteriorated. It's only because of nanoparticles. We have nano acephate, nano hydrochloride, nano mango jab. These are all different nano pesticides which are available in the market. We have nano phosphorus, nano sulfur is also available in the market. Now, this nanotechnology in the field of agriculture is the best alternative example as far as pollution control at the source itself. The control strategy at the source itself. This nano pesticides and nano fertilizers are the best examples here. Now, why it is due to? Because of the large surface area and high surface energy, the catalytic reactions and its absorption capacity. All these are advantages as far as nanoparticles are concerned. Now, what we are expecting nanotechnology development, what we are really expecting, our talk here is only the reduction of energy and materials usage and a cleaner environment. the pollution control. Nanotechnology used for pollution control. That is, we are expecting as far as nanotechnology. A huge advantages for us. Look at the electronics, nanoelectronics nowadays. It's so famous. Look at the size of the computer 50 years ago and now the size of the computer. Look at the mobile phone 30 years ago, the size of the mobile phone. We are having smart materials, nanomaterials. Look at the role of nanotechnology in the mechanical engineering. So, in other fields, we have expected results are there. But pollution control, certain areas, and we are getting positive results in the coming slides. I'm going to show you. No, this is the latest one. What are nanotechnology socks? The nanotechnology socks contain nanoparticles of silver. Now, these particles certainly helps the killing the bacteria that makes our feet smell. And many people with smelly feet will benefit from this technology. No, this is the latest one. Small is beautiful, I'm telling you. If the particle size is less, and how it enters into the bacteria and how it is going to kill, almost like a pesticide. No, we have nowadays. People, they will. Subbarao Garu? Any problem?
No audible. Small interruption is there. Just small interruption.
So from my side, if there is no problem.
We are also. No, continue. Please continue.
Can you hear me, Subbarao Garu?
Okay, please continue. Venugopal, please continue.
Subbarao Garu? Did you see?
Yeah, please continue.
Yeah.
Please continue.
Yeah. Thank you. Yeah. So nanotechnology stocks, and I told nanopermethine, which is used by our Javans, and they will apply this nanopermethine to their fabric, and they will go into the deep forest. If any bacteria or any fungi or any insect falls on their fabric, it will die. So the role of nanotechnology is so crucial. Yeah.
So zoom the slides.
Yeah. No, it is already in zoom mode. It's not visible to you? It's not visible?
First slide.
Okay, move the slide. Now it is first slide.
Yeah, okay. Just a minute, I will do it again otherwise. The technology is interfering us. Yeah, again I will do it. Is it okay? Now it is okay?
Okay.
Okay, we'll go there.
Okay, proceed.
Yeah. So, nanotechnology and why nanotechnology means you understood the advantages. Yes.
Again, we'll come back to the first slide.
It is not coming?
No.
Can I share it again? Otherwise, I will stop sharing. I'll do it again. Just a minute.
Okay. No problem.
It's okay?
No.
It's okay?
Okay, press.
Yeah.
Proceed.
Yeah, it is in zoom mode only. It's okay?
Okay.
Right. All advantages, and these are the various fields where nanotechnology has got. Not okay? Subbarao Garu?
Just 1 minute.
Yeah.
Just 1 minute. So you back to first slide.
It is going to first slide. Again, I'll do it as this. Now it is okay?
No.
Still in first slide?
First slide.
Now it's okay?
No. Now it is first slide.
It's okay now?
Okay, now. History of nanotechnology.
Okay. Yeah. Okay, fine. So when we talk about nanotechnology and its importance, and these are the three great people who are the initiators as far as nanotechnology is concerned. Because of them, now we are using it for our pollution control also, is Feynman, Drexler and Norio. These three people have contributed a lot as far as nanotechnology is concerned. Now, these are the various fields I already explained to you. Let me skip. Now, as far as nanoparticles are concerned, we divide into four categories: 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional. For our pollution control strategies, we will be using 3-dimensional nanostructures. In the coming slide, I will show you. Now, the role of nanotechnology in pollution control. All over the world so far, these are the three areas where the nanotechnology is used for pollution control. The source reduction or pollution prevention, and remediation or degradation of pollutants, and sensing of pollutants. Three pictures I have shown. I don't know whether participants can see my slide or not. Sparrow, can you see my slide?
Visible.
Is it okay?
Okay. Is it okay? Proceed.
Okay, fine. So the first one is how nanotechnology we are going to apply as far as the three phases of environment. We will think and prefer about liquid phase. How best we treat water. So
Hello. Venugopal. Hello.
And similarly, the
Venugopal.
hello. Is there any problem?
No.
On my side, it's okay.
Okay.
Yeah, from my side it is okay.
Okay.
Yeah. Can you see the slide?
Okay. Nanotechnology application 3 pages.
Yes.
Okay.
My side it is okay. I think their power problem.
Okay.
Anyway, the liquid phase, gas phase, and solid phase. These are the three things. Nanotechnology has got very good results as far as soil remedy and pollutant gas sensors and water treatment. And these are the three areas we should certainly understand how nanotechnology helps us. Coming to air pollution can be remediated using nanotechnology in several ways. And one is through the use of nanocatalysts with increased surface area for gaseous reactions. Catalysts work by speeding up chemical reaction that transform harmful vapors from cars and industrial plants into harmless gases. Now, why I have shown this particular thing? That means we can reduce the gases that are coming out from an automobile setup at the source itself. We are using nanotechnology. After going through the treatment, the gas that is coming out in the form of exhaust, and we can easily control the pollution at the source. The nanotechnology helps us here. Even then, if the gas is emerging out from the exhaust or the smoke tag in industries, we can easily sense whether the pollutant concentration, so that we can go for a remedial measure. So in both ways, nanotechnology is helping us. One is it is helping us at the source, reduction at the source. Another one is it is going to give sensing, pollution, detection. Different types of air contaminants in general we are having. If it is a gas contaminant, look at the particle size, 0.1 to 1 nanometer. Particulates are 10 to 100 nanometer. Dust, it is a little bit bigger particle, 1 to 100 micrometers. And biological contaminants also 1 to 100 micrometers. And heavy dust, 100 micrometers to 1 millimeter. Now, we have strategies up to dust. Up to dust, we are having traditional methods and all other novel strategies are there, either to prevent them or to sense them. But particulates and gas contaminants, innovative technologies are required. That is nanotechnology. Nanotechnology certainly helps us for gas contaminants and also particulates. If it is a dust, biological contaminants, heavy dust, we have all best practices, what I have shown in my earlier slides. And those strategies are much more comfortable. But gas contaminants and particulates, we require innovative technologies are possible. This control of air pollution. Catalysts currently in use include nanofiber catalyst made of magnesium oxide that removes volatile organic compounds. So, nano magnesium oxide certainly removes volatile organic compounds from industrial. The latest attempt all industries are doing. And carbon nanotubes for trapping greenhouse gas emissions caused by coal mining and power generation. And carbon nanotubes can trap gases up to 100 times faster than other materials. So the magnesium oxide technology and also carbon nanotubes, and these are the leading nanotechnology attempts for control of air pollution. And nanobioremediation is another important strategy that all industries are following. Now, the use of nanoparticles and nanotechnology to enhance the microbial activity to remove pollutants and also enhance bioremediation. And this particular area where people are getting good results as far as the pollution control is concerned. Because if it is a less concentrated site, people are employing nanobioremediation strategy and they're getting good results. That is also another tool as far as nanobioremediation is concerned. Now, metallic iron. Now, all countries in the world they prefer this particular strategy. Nanoscale, the use of nanoscale metallic iron. Very effective in destroying a wide variety of common contaminants, such as, look at the list, chlorinated methanes, brominated methanes, chlorinated benzenes, ethanes, and polychlorinated hydrocarbons, pesticide, dyes, etc. The basis for the reaction is the corrosion of zero-valent iron in the environment. So nanoscale zero-valent iron can reduce not only organic pollutants but also inorganic species like nitrate, perchlorates, chloride, selenite, arsenide, chromate. So 25 to 30 times faster reaction rate and absorption capacity than normal granular iron. That means if you prefer normal granular iron and with the nanoscale metallic iron, I told you when the particle size is reduced, look at the enhancement in the property. So if the nanoparticle 20 to 50, 30 times of faster reaction rate as compared to normal granular iron. And pollutants remediated by iron nanoparticles. All countries in the world now they prefer iron nanoparticles just to treat all the list. What I have shown you in the slide, we can easily remediate by applying iron nanoparticles. So nano remediation and iron nanoparticles, what are the different advantages we are getting means, as I said in the beginning, if the less amount is used, the less extent of pollution we receive at the end. So, and important thing is easier we can separate, we can reuse it, cost effectiveness, and it has some magnetic properties. And nanoscale iron is abundant and far less toxic than other heavy metals. And aggregation of these particles is responsible for reducing surface area to volume ratio. So these are all benefits that we are going to get from iron nanoparticles, especially for pollution control. And treatment and remediation. three major ways we can do it as far as nanotechnology, application of nanotechnology is concerned to reduce the different air pollutants. One is adsorption, and a few minutes ago we have seen nano metallic scale iron, how it is going to absorb the various organic pollutants, which is far superior than the normal granular iron. So that means adsorption, degradation by catalysis, and filtration and separation by nanofilters. So these are the three techniques we can easily apply as far as nanotechnology for pollution control, especially in the field of air pollutants. And look at the type of nanoparticle nowadays we are using, and what sort of treatment we are doing, and what should be the target. Organic pollutants is the common target for us. If you adopt a photocatalytic oxidation, the best one nowadays, the best alternative is nano-based titanium oxide. And for heavy metals and organic pollutants, if we follow adsorption technique, the best technology we are adopting is nanoclay. And nanotubes and fullerenes also for heavy metals and anions and organic pollutants. So we have so many options for us. If nanofiltration and nano sieve membranes we use for the removal of organic and inorganic compounds, and which is actually used for liquid phase pollutants, that is nanofiltration treatment, we can use definitely a nanofiltration or nano sieves. Now, the best nano sieves, that means carbon nanotubes, we are using for the removal of organic and inorganic compounds. So there were many applications in different environmental areas as far as the various type of nanoparticles are concerned. And every industry, they are using nanocatalyst. The advantage is 1 to 10 nanometers. That is the size I told you. Look at the advantages: high activity, high selectivity, excellent stability, easily separable, energy efficient, and atom economy. So these are the benefits why nano catalyst people are actually adopting. And pollution detection and sensing. As I said in the beginning, application of nanotechnology is to reduce the pollution at the source, and also to detect the pollution or to sense the pollution. So detection and sensing in this area, and we got very appreciable results as far as nanotechnology is concerned. Silver nanoparticles, water quality monitoring, carbon nanotubes, electrochemical sensors, carbon nanotubes as building blocks, which is for exposure to gases like oxides of nitrogen and ammonia. So we have in the market the sensors which are based on nanotechnology, which will certainly detect the pollutants which are in water or which are in the upper atmosphere. And sensing a pollutant, I told you, detection of organic pollutants, inorganic pollutants, and biological pollutants, we are applying nanotechnology. The ability of the nanoparticles, which is to be coated with a wide range of chemical and biological ligands, helps in giving the specificity to the sensor. For example, nowadays we are doing encapsulation techniques. That means the material is encapsulated with a nanofilm or a nanoenvelope. And when it is subjected to the target, first the nanoenvelope starts undergoing dissolution, and later the active ingredient is touching the target. This is called controlled release formation. Especially in the field of agriculture, to reduce the agricultural water pollution or the agricultural waste pollution, we are using this nano encapsulation techniques, or the nano encapsulation of pesticides, nano encapsulation of fertilizers. So nanoparticles which are actually helping us in slow and controlled release of the active ingredient. That means which itself reduce the pollution. And nanofiltration is the another, I think, achievable technology as far as pollution control is concerned. We all know nanofiltration membranes are used in water treatment for drinking water production and wastewater treatment. Nowadays, when we purchase a water filter of a very high cost, definitely it has nano membranes. NF membranes are often used. So when you have the filtration at the beginning itself, that means the pollutants are easily separated. That means you are allowing in the liquid effluent very less concentration of pollutants. That means you have control at the source itself. So nanofiltration membranes are pressure-driven membranes with properties between those of reverse osmosis and ultrafiltration membranes have pore sizes between 0.2 and 4 nanometers. Now everyone is saying reverse osmosis and ultrafiltration are the latest techniques. Now we have enough technology, that is nanofiltration technology is also a superior one, which is giving good results for us, especially for water filtration is concerned. When you talk about carbon nanotubes have been arranged to form a hollow monolithic cylindrical membrane which was efficient for the removal of bacteria or hydrocarbons that can easily be regenerated by ultrasonication or autoclaving. Here there is a third dimension of nanotechnology is not only it is sensing the pollutant and it is separating the pollutant, and it is also helping in retrieving the pollutant, retrieving the active material, useful material involved in it. That means for regeneration aspects it is applying, for sensing it is applying, and also for control also we are using. So the role of nanotechnology for pollution, pollutant separation, pollutant sensing, and also the important or useful material present in the pollutant chemical regeneration also, we are employing the nanotechnology. That is a very, very important thing. And when we talk about organic pollutants, nowadays porous silicon exhibits the phenomena of photoluminescence, and this luminescence is quenched in the presence of organic molecule. By using this technology, pesticide concentration as low as 1 ppm could be detected. Nowadays, water containing organic pollutants, inorganic pollutants, and biological pollutants, whether they are in suspended mode, dissolved mode, in whatever the mode that is present in water, we are in a position to isolate it. And even the reverse osmosis can isolate even the colloidal silica also. Even up to 2 ppm also we can easily isolate. But the nanotechnology or the nano what we have developed nowadays, it can also even remove 1 ppm colloidal silica also. It can also detect even the pesticide molecule where its size is even less than 50 nanometers also, it can easily detect. So the organic pollutants we can easily separate by using nanofiltration membranes. And as I said, we can also sense inorganic pollutants also. Detection of heavy metals like lead, mercury, cadmium. We can also detect by using nanomaterial. That means nanotechnology is to sense inorganic pollutants also. When we sense, for example, mercury in water, now we have a sensor which is a nano filtration membrane which can sense even 20 ppm of mercury present in water also. And we can easily sense mercury. If it is less than 5 ppm also, we have a mercury sensor that is also available here. For sensing inorganic pollutants, nano materials are very, very crucial. Sensing of biological pollutants. Using gold nanoparticles, popular one. They can easily sense the S series, what do you call, even the bacteria or the algae or the antibacterial materials concentration also we can sense. We can easily calculate even with the gold nanoparticles. And detection of certain microorganisms, we can also use quantum dots and fluorescent. This is a patented one. There's a slide in which you have seen gold nanoparticles and quantum dots. This technology is a patented one. It's a costly technology as far as the control strategy information is concerned. Nanotechnology and the environment. As I said, nanotechnology is useful for pollution prevention and its treatment, remediation, and you can also give a lot of information for the awareness purpose also. So that is a major important thing from as far as nanotechnology has the potential to sustainably benefit the environmental quality and sustainably through pollution prevention, treatment, remediation, and information. This is the thing. Now, sense and shoot approach to pollution treatment. And I have explained about the metal oxide nanoparticles. This is zinc oxide, and earlier we have seen magnesium oxide for organic pollutants and inorganic pollutants. Now, zinc oxide semiconductor film as a sensor and a photocatalyst. Now, how it is helping us? Nano-sized zinc oxide, it is sense organic pollutant indicated by a change in the visible emission signal. That means how we are understanding it is a transformation of a property to another property. We can come to an inference. That means nano-sized zinc oxide, it will sense the organic pollutant. How would we know that it is sensing organic pollutant, which is indicated by a change in the visible emission signal? And that means that is how it is going to sense. The zinc oxide shoots the pollutants via photocatalytic oxidation to form more environmentally benign compounds. Sensing capability means that the energy consuming oxidation stage only occurs when the pollutants are present. That means multifunctionality and smartness is highly desirable for environmental applications. You cannot have a direct approach. Nanotechnology in this particular example has an indirect approach. First, it will sense organic pollutant. Later, it will undergo some sort of a photocatalytic oxidation. Then we can easily isolate it. That means a sensing and a shooting approach for pollution treatment by zinc oxide nanoparticle. That is a very, very smart and multifunctionality as far as nanotechnology for pollution control is concerned. What are the challenges of nanotechnology as far as the pollution control is concerned? We have to develop a direct technology and understand its implications, and you have to prepare solutions and implement globally. If a nanoparticle which is fit in trapping the pollutant in the surrounding areas of a particular industry should have the same phenomena when it is applied to another industry, irrespective of the atmospheric regulation change or change in the atmospheric regulation. Then only we can adopt the technology. Then only the outcome is commendable. So that is the challenge of nanotechnology. In the earlier cases, we have seen nanotechnology SOX and nanotechnology which is fit for sense and shoot of certain pollutants, biological pollutants, organic pollutants, inorganic pollutants. So that technology should be applied in all areas. That is it should be fit for global challenges. So that should be the thing. Even in pollution control also, whatever the nanotechnology initiative we are doing, it should be fit for all conditions. That is the challenge for world scientists. And coming to the conclusion, according to the existing nanotechnology initiative as far as pollution control and the work done so far across the world, we have enormous examples are there. Nanocatalysts, bioactive nanoparticles, nanosorbents, etc. But when we talk about the disadvantage, means it is expensive. Yes, but in certain areas, certain strategies, though it is expensive, we will be getting very good results, and we can easily control pollution to almost we can reach 95% also. So the development of nanotechnology for pollution control is a continuous process. All people in the world, they are doing this particular field of research. So the most noteworthy part is nanobioremediation. So this nanobioremediation is the successful nanotechnology initiative for pollution control. Thank you, and thanks a lot. If you have any queries, we can easily discuss.
Thank you, Venugopal, for your wonderful presentation covering all types of pollutants and role of nanotechnology in various dimensions. Now we will now have a question and answer session. Some participants are asked.
Yeah,
please tell. Rashmi Ranjan Mohapatra asked one question.
Yeah, please tell me, sir.
What are the amended points included during draft year 2020?
Yeah. Can you say again? It is not audible for me.
What are the amended points included during draft Environment Act of 2020?
Yeah, but as far as the nanotechnology, our country is having nano mission. Nanotechnology is concerned, we are not having what you call the drought situation. The role of nanoparticles in the drought water, when we think of drought water, the more number of organic pollutant concentration is noticed, and dangerously to about the particulate matter, it reaches all 300 nanometers. Up to 300 nanometers, we could easily 300 nanometers. That means in some certain materials, we can reach even 80 also. For example, for pesticide particles, 80 nanometers, up to 80 nanometers, we are having technology. We can easily trap it. And for other materials, inorganic or organic pollutants, and sometimes we can easily get if the particle size is less than 100. But in drought situations or torrential rain comes in water, there are certain particles where we can easily isolate if it is in micrometers. But if it is in nanometers, we have ultrafiltration technique, a nanofiltration technique, we can easily do it.
Venugopal.
Yeah.
Actually, the question is related to what are the amended points draft in Environment Act 2020.
2020 as such nano what do you call technology for pollution control, there is no much difference as far as the amendment is concerned. There is no latest amendment as far as nanotechnology is concerned, right? So for control of air and prevention and control of air pollution act, we have some amendments, but nano technology is concerned, there is no much change. Existing only we are getting. No change in the Amendment Act.
So one more question by Rashmi. What are the innovative solutions available?
Yeah, the innovative solutions we have, for example, you take the fertilizer. We have nano fertilizers are available. You take pesticides. Nano pesticides are available. Even preservatives, food preservatives, it is a wonderful achievement in the world. Nano food preservatives, and the nano food preservatives will be getting a huge amount of successful results. High shelf life we are getting. So there are many, even nano drugs. Nano drugs are the agricultural waste in which, if nano fertilizers and nano pesticides are employed, the agricultural wastewater analysis, if you could perform, drastic difference as far as traditional method compared to the best alternative nano method is concerned. So there are so many innovative are there. Even nano syrups, and that is the nano syrup. Even we can take rather than 2.5 ml, we can take 0.5 ml. That is a wonderful innovative practice we are getting. So wherever the possibility of getting adverse effect to the environment from the material side, even in the material science, this role of nanotechnology has got a pivotal role.
So, one more question.
Yeah.
Prabhat soil. Yeah. How can we minimize heavy dust in urban areas?
Yeah. We have a heavy dust sensors. Now dust sensors are there. In certain companies are producing dust sensor. Even that dust sensor can go up to 50 micrometers if the particle size is. Even up to 50 micrometers we have got dust sensors. Now coming to nanotechnology is concerned, still research is going on beyond that. That means we are entering into nanometers, nanometers range. Right, so up to 50 micrometers, we'll be having the dust sensors which are available in the market. Now, within a few months or within a less interval of time, we will be having a nano sensor which can easily trap dust. Even the particle size is around 90 nanometers, less than 100 nanometers. 300 nanometers, we have a company dust sensor is available in United States, but no information, clear-cut information. It's a patented one.
So one more question.
Yeah.
How to overcome pollution due to e-waste?
E-waste. Yeah. As far as e-waste is concerned, we are going for traditional method only. The e-waste, in which we will be isolating the heavy metals, we will be isolating the precious metals, and the so-called traditional methods we are employing. And if it is a liquid, if we could convert into a liquid form, and we have nanotechnology role is comfortable. But the point here is how best we will convert e-waste into the end stage into a liquid form, or gaseous form is very, very difficult. But if you could convert into liquid form, the role of nanotechnology, we can take the help of nanotechnology and we can easily minimize it.
Okay, one more question related to water.
Yeah.
How to reduce arsenic content in the water? Reduce of arsenic.
Yeah, that's true.
Maybe by nanomaterials.
Yeah. And we have a study, 0.5 up to 0.5 ppm level of arsenic detection and sensing. We are having several technologies are available. Coming to nano technology is concerned, and people are now still it is in the infancy stage of detecting even 0.1 ppm or 0.05 ppm of arsenic detection comfortably by using nanotechnology is concerned. Still it is in the research mode only. If it is more than 0.5 ppm, we have several sensors are available. Sensing the arsenic technology is available for us.
So, one more question related to e-waste. Question
Yeah.
asked Dr. Arpita Chatterjee.
Yeah.
So, say few words, tell information on e-waste.
Yeah. But the problem here is electronics can consist of toxic components, maybe mercury and chromium. So when the devices are not properly disposed, then it can lead to soil and water contamination. However, e-waste typically ends in landfill sites in all countries. Now, how best we are doing means we have to reduce at the source itself, but only the existing nano sensors as far as heavy metals are concerned, and which are involved in zinc oxide or cadmium oxide particles, we are actually using to trap the heavy metals, especially in e-waste. Typically, we have technologies for chromium and mercury. We have nano sensors are there for detection of chromium and mercury, but other heavy metals is still it is in the development stage only.
Okay, thank you, Venugopal.
Okay, thank you, Venugopal.
Yeah.
On behalf of our department as well as on behalf of our college, so thank you very much for your wonderful presentation. Okay, today's session is over. So to all participants tomorrow join 1:20 a.m. Tomorrow for second day.
Thank you, Dr. Subbarao. Thank you to the HOD and Principal GMRIT for giving me this opportunity. And the best alternative or the latest alternative is the order of the day. Thank you.
Okay. Hello. Okay. Tomorrow 10:20 a.m.